Hey guys, welcome to increasing decreasing intervals and the first derivative test part 2. In the last video I gave a introduction of what a function is decreasing and increasing and how the derivative plays into effect of that. And I also talked about how a maximum and a minimum occur when you have the slopes of the function. So in the last video we began this example and I couldn't finish it because of time. So we are supposed to find increasing, decreasing intervals of this function and maximum and minimums. And the only thing that I've done was identified what my critical numbers were. And I have to plug these I have to find numbers around my critical numbers so that I can test for the signs of the derivative. So we chose -2, 0, and +4. So let me go ahead and continue. If I plug in -2 into my derivative, will this derivative be positive or negative? So let's go ahead and check. And I get +4 plus a +4 and then -3, which means I have a positive interval. Now notice, I'm not really interested in what the actual derivative is. I'm only interested in whether it's positive or negative or 0, which means that from left to right, let me go ahead and draw my number line a little bit better. Here's what I want you guys to do. I want you guys to do what I'm doing. So draw your number line like this. And then on top, I want you guys to write f prime. On the bottom, I want you guys to write, let's do it like this. Yeah, let's do f prime and then f here. So the derivative at -2 is positive, which means the derivative here is positive from -infinity to +infinity, which also means that my graph is going up from -infinity to 1 to -1. So let's go ahead and test 0. 0 is very simple. If you plug in 0 into your derivative, you just get -3, which is less than 0, which means that my derivative at 0 is negative, which means that my derivative should be negative from -1 to 3, or my graph should be decreasing from -1 to 3. Now notice, these are my critical numbers, which means that my intervals of increasing, decreasing has to be in between these numbers or outside of these numbers, but not including those numbers. Let's try +4. If I plug in +4, I get 4 squared minus 4 times, well, let me do it like this. 2 times 4 minus 3, which is 16 minus 8 minus 3, and that is definitely positive, which means I have a positive f prime, which means that my graph is going positive from 3 to infinity. Now, what does all this mean? Well, let me erase this so we can see. When the derivative goes from positive to negative, what do we have? Go back to your notes. Positive to negative means we have a maximum. Notice I did not need a graphing calculator to tell me that. I used calculus. I have a maximum here at -1. This critical number provided a maximum. What about from negative to positive? If you go back up to your notes, you get a minimum. So let's go ahead and answer the question. F is increasing and decreasing where? From where to where? Well, F is increasing from -infinity to -1 and 3 to +infinity. Why? You should never answer something without saying why. And you just can't say because the graph is going up. You have to use calculus rationale to explain. Because f prime of x, the derivative of f, is greater than 0. So that means that f is decreasing from -1 to 3. And then because f prime is less than 0. Now the next thing we have to answer is maximum and minimum points. Well, I've only found the maximum x values and minimum x value. I haven't found the actual point, so what I need to do is write down the point. So how do I do that? I plug those points back into my function. Okay, let's do the easy ones first. -1 squared is +1, so it's a -1, +3, +2, and this is supposed to be a -1/3. Let's add up the whole numbers first. I should get a +4 and -1/3, which is a -1/3, plus 12/3, which is a +11/3. So that means that f has a max at what is the x value? -1/11/3, because, or you can abbreviate because f prime changes from, well, when do you have a maximum? A maximum occurs when the derivative goes from positive to negative. Now let's go ahead and find our minimum value, f of 3. F of 3, let's go ahead and plug that in. So it's 3 cubed minus -1 squared. Oops, I'm doing 3, not 1. 3 squared minus 3 times 3 plus 2. And I get 1/3 times 27 minus 9 plus 2. This becomes a 9. So I have 9 minus 9 minus 9, which is -9 plus 2, and that is -7. So I'm going to say f has a min at 3, -7, because f prime changes from negative to positive. And this is my answers. Now I'm not going to draw a sketch because I definitely don't have enough room, but here's what I will do. I will graph this in the calculator, and I will tell you, and I will show you guys, just by looking at this information right here, I can tell you that the graph looks like this. Let's see. It should look something like this. I mean, I'm not going to draw a perfect graph, but it should be going up and then down and then back to up, according to what my evidence here. So I have just enough time to show you guys the picture of the graph. So let me go ahead and add a new document. And here I have -1 divided by 3, and then x to the third minus x squared. What else do I have? Minus 3x plus 2. Oh, okay, well, I'm having a hard time with my calculator. Anyways, ignore what I just started doing. If you graph this on a calculator, you guys will see how the graph looks like. It should be a cubic function, minimum, maximum at those points, and increasing, decreasing intervals. See you guys in the next video.